Hello guys, today we're finally going to cover the machine learning roadmap that I exactly followed to transition my career from a business consultant to the machine learning engineer. I know many of you have requested for this series, apologies for the delay in delivering. I've divided the roadmap into 6 different phases that you can follow step by step. Today I'm going to cover about what kind of learning materials that I've used, what kind of things you should be focusing on, and what kind of things you should be aware of. And this roadmap, I believe, will save tons of your time and help you learn AI faster than anyone. Let's dive in. I've listed down over here. It took me about a year and a half to consider myself as, oh, I know some stuff. I might be able to apply for ML engineer role. It doesn't mean that I've completely mastered everything in a year and a half. I've divided my study stage into 6 different phases. The first thing I did was studying about the Python, SQL, all the basics that I need to master before going into machine learning or any other deep learning stuff. The next step, it took about 3 months, is about the Python for machine learning. There are Python libraries in particular that you should feel comfortable using it. So it took about 2 to 3 months to learn things. And this phase 3 is a competition part. This is ML or data science related competition. I've overlapped this phase across not only here, but also across phase 2 to phase 4, because this is very crucial part which I'm going to emphasize on later that you should keep in mind. The next thing, after you have learned the basics about the machine learning for Python and join some competition, in parallel, you should be doing a deep learning. Deep learning is the part that you'll make yourself accustomed to PyTorch, TensorFlow, other deep learning Python libraries that will help you to build those models. And phase 5 is where you specialize. It might be difficult to grasp at this point, but specialize is about choosing your particular interest in AI. There are many different AI fields, which I'll show you in the mind map later. But this is about the time you need to think about which field in AI that I want to specialize in. And phase 6 is ongoing phase from after you master machine learning, deep learning, and join some couple of competitions. And it's the time you should be able to build and ship your product. This requires more extra software engineering or data engineering knowledge, but this is very crucial. So you can kind of see the flow of how I started and try to build up my knowledge step by step. And I've listed down over here. So from phase 1 to phase 6, phase 1 is something that will be covering some of the requirements for the data analyst. Phase 2 to 3 across phase 4 is for the people who wants to be a data scientist. From phase 4 to phase 6 is more of a focus on a machine learning researcher position. But I'm not telling you that after you go through phase 1, 2, 3, you'll definitely be a data scientist or data analyst. It means that you will have a knowledge base that you can apply for those positions. And you might wonder, how much time did I dedicate? How much time did I spend that I was able to gain all those knowledge in about a year and a half? The reality is quite brutal. I spent about 8 to 10 hours a day studying it because by that time I quit my job from consultancy to switch my career to AI. So I had my full day, but I was under the pressure that I really want to switch my career as fast as I can. So I dedicated 8 to 10 hours nonstop, about 12 to 18 months. So I would say this is more for people who want to do a full-time career switcher like myself. But if you're working right now and if you want to find a sweet spot for working adults learning after work, then I would recommend studying about 4 hours a day. But you might need extra months to study all these phases. And if you're more of studying AI for a hobby and you want to make a meaningful progress, but you don't have enough time, try to spend at least 2 hours a day. As I've written down over here, this is just a general guidance. Learning time can vary depending on the learning speed, your background knowledge. Also, by the time I was studying all these, ChatGPT wasn't a thing. So I didn't have much resource to ask GPT explain this concept in an easier way or make a customized learning material for myself. So I believe if you're a fast learner and if you can leverage existing AI tools, you'll be able to learn a lot faster than I did. Moving on to any further phases, one by one, I want to emphasize on 5 different principles. First is learning something is very hard. There's no shortcut to a career someone else have spent years and years on. This is something that I learned because I'm a very impatient person. I'm always in rush to achieve something as fast as I can. So I was very frustrated. I was depressed. I was crying in front of my desk. And then my mom told me, the thing that you're trying to achieve here is something that people have spent hours and hours, the years, trying to build their career. And if I can just achieve that very easily, it doesn't make sense. You need to accept the fact that you will need to save yourself a lot of frustration. Second is you'll never understand anything 100%, but don't let that stop you. Because all the concepts that you'll be deal with is very unfamiliar. It's difficult to understand and say, oh, this makes sense. It's not like 1 plus 1 is 2. So you need to be consistent about not knowing. This consistency will build the comprehension that you'll be looking for. And third is practice makes it stick. Read a lot about what the codes, the explanation, the tech blogs that people have wrote down, and you need to write codes with your own hands. Some people say because of AI, the software engineer is disappearing and writing code is not really a special skill at this point. But I don't fully agree because if you want to call yourself as an engineer, you need to know how to write a code. You need to have a skill set that you can read the code, interpret it, and also find out what's right and what's wrong. Fourth is stay open. AI moves very fast, as you have witnessed lately. There will always be something new. For example, when I started learning machine learning, there wasn't much emphasis on reinforcement learning or AI agent. There was no vocabulary about AI agent at all. But it's one of the biggest things that everyone talk about, right? So if something new comes out, you should have an attitude like, oh, what's that? I want to learn those new things. You shouldn't be like, oh, I don't want to study further. So try to change your attitude to being more open. The fifth is you'll feel rushed all the time, which I have the most trouble dealing with because I've told you before, I'm very impatient, very rushed to achieve things. But you need to ignore all the noise and study at your own pace. I wouldn't recommend to everyone, but what I did is I went back to my hometown in Korea and then I just didn't meet anyone for about a year. I just stayed inside my room. I studied. I focused on what I learned today, what I'll learn tomorrow. But what I mean is try to ignore all the noise, all the advertisement saying like, oh, you can learn AI in 5 minutes, 1 week. It doesn't make sense. You'll not learn AI in 1 week. You'll not learn AI in 1 month. It needs time and you need to put yourself to learn all the things. Now, welcome to phase 1. Phase 1 is focusing on Python and data analysis. As I've written down over here, it's not about mastering Python. In this stage, you need to focus yourself being comfortable enough with the code writing and how to load the data, how to pre-process the data, what kind of different data format exist. You have to have a solid understanding about the code itself and the data. This stage is very important because the other phases is dependent on this. If you don't study this phase 1 concretely, you might end up coming back to phase 1, which you will waste so much time. The tools and Python libraries that you should be focusing on is of course Python, Google Colab tool. This should be your best friend, either Google Colab tool or a Jupyter Notebook. These two are something that you should be using intensively. Or you can use any coding IDE, try to write your code on your laptop. The libraries that you should be focusing on is a NumPy, Pandas. I've written down or Polars. Polars is some other Python library that has been gaining popularity. The grammar syntax is very similar to Pandas. So if you become familiar with Pandas, you'll be easily able to pick up Polars. Some people say the Polars is about 5 times faster than Pandas. So I've been trying to switch towards Polars, but Pandas is also very important because some of the machine learning libraries are not really compatible with Polars data frame. So try to start with Pandas, and if you have time, try to move on to Polars. And this Matplotlib, Seaborn, Plotly, Folium, these are the data visualization library. Some people might say, oh, I want to be a machine learning engineer. Why do I need to know the data visualization? Because if you do a data analysis and if you want to see something more intuitively or even explain it to other non-technical people, you might end up using data visualization anyway. And it's not too difficult. These Matplotlib, Seaborn, Portfolio, try to make yourself familiar with very common plot types, bar graph or accumulated bar graph, pie chart, violin plot, the different kinds of plots that we commonly use in this machine learning field. And if you haven't used GitHub before, try to sign in yourself into Git, play around the common Git commands, clone your GitHub repository, try to make a pull request, try to make a commit. Just this is the phase that you should prepare the basis of everything you'll be doing in the future. In machine learning, SQL is not 100% mandatory, but I think this is very important if you're interested in doing more data engineering stuff. Because what machine learning engineers do, if they want to build a model, they need the data, right? But if you want to deal with data, you need to know how to bring in the data. And in this phase, the SQL can do some magic. And in this phase one, these are kind of checkboxes that you should be ticking off before moving on to phase two. First, you know the Python basics about the loops, functions, dictionaries, comprehensions, classes. And second, you can comfortably solve LitCode entry level. LitCode and HackerRank is one of the most popular platforms for your programming. Just bookmark those websites and try to go in every day and try to solve LitCode Python questions. Third is you can load, clean, and visualize messy CSV or XLSX in under half an hour. You should know how to deal with data, how to drill into data, because sometimes if your model is not working well, you need to zoom into data. And if you don't know how to deal with data, that's very problematic. And the other thing is your code needs to follow the basic good practices. What I mean by here is in this phase one, you shouldn't be just oh, I know how to write a code with Python. You should be like, I know how to write a good code with Python. This is very important because if you get used to writing messy codes, you will not pass any coding interview in the future. You need to read lots of good code, efficient code. You need to take your time solving a lead code and looking at, oh, what's wrong with this code? What are the better ways that I can write? This is something that you wouldn't be able to understand unless you spend time and try to think about what's the good code, but you'll understand it in the end. The other thing is you should create your GitHub repo, make first commits, and fork other repos. What I did is I tried to spend about at least 10 minutes, maybe half an hour a day, just going into GitHub repository. I'll just sneak in and pick into the different GitHub repository and try to see what people wrote. Try to see the issues people have flagged, what kind of pull requests they have made. This kind of daily observations on other people's code, it'll be a big asset for you in the future. So milestone outputs. When you pass this phase one stage, you need to have enough Colab or Jupyter Notebook or Kaggle notebooks that you have written down your own code. The other thing that I would recommend is try to start your tech blog while you're learning these things. Because for me, when I study anything, I try to keep a record of everything. I used to write everything like a journaling about the things that I've learned, about the Python, or I would write things on my own notes by hand. This is really helpful and it'll track down your learning footprints. If you're confused about something, you can definitely come back and then look up these notebooks. Here are common mistakes that I really want to share with you guys. First, never watch tutorials forever. Never be caught up in this tutorial loop. I think at first I was like, oh, when I watch this tutorial, it means I know this, right? But it's never the same. I used to speed up in 2 times faster speed, and then I'll watch 5 hours of tutorial in just 2 hours and just try to move on to writing code part. Learn fast and try to move on to writing code part as soon as possible. This is very important because if you're just caught up in a tutorial and just keep watching it, you'll easily get bored. You'll feel like, oh, this is not fun at all. Writing code is a very fun part of being an engineer. Oh, I have also written down here, repeated myself, you should speed up the basic tutorials. I've capitalized here. Watching tutorial doesn't mean you know what you watch, right? You should move on to writing and understand codes, go back to basics, and write the code again. And similar to the context of what I mentioned about tutorial, don't be a certificate collector. When I first started learning machine learning, I signed up myself in many different private certificates in Korea. One of the certificates that I got was like data expert certificate. But honestly, that certificate is not bad if you're interested in giving some particular knowledge, but I wouldn't recommend because it's easy to be caught up as a certificate collector. On LinkedIn, many people all know, oh, I'm proud to announce that I've completed the certificate. It's good, but you shouldn't always do that. Certificate doesn't equal things. And the other thing is start from the messy code and try to write a good code. I think one thing you can try is ask AI for your code review. Write down your code and ask about, is my code readable? How's the space complexity? How's the time complexity? Is there a way I can consider? And I've also listed down some key resources that you can take a look. Of course, I've listed down my video. I published a video about how I learned Python. So you can take a look and see what kind of strategies that I've used. I've also linked about my blog post about the Python resources you can take a look and some basics about the Google Colab and some of the sources that I've used when I was studying NumPy, Pandas, Polars. Things like NumPy and Polars, their official documentation have pretty good quality resources. So I would recommend bookmark those things, try to go back and write down your code and debug it while looking through the documentation. I know because of AI, reading documentation is such a time-consuming thing to do, but as a beginners, I would highly recommend doing it. The data visualization, these kind of libraries, I've written down here. The thing you should keep in mind is while you do data visualization, don't focus on making a pretty looking graph. If the pretty looking graph can't deliver any messages, it's nothing. It's just meaningless time consumption. So keep thinking about what's the purpose of this visualization. What are the things that viewers can learn and what you can learn and what kind of meaning it encompasses inside this data analysis. And I've shared the lit code link. Try solving 1 to 3 questions a day. I should probably get back to lit code, but it's a really nice habit that if you solve daily lit code, it's not only helpful for you to refresh your memory about the basic syntax in Python or any other language, but it'll also save you so much time if you sign up for a coding interview in the future. And SQL, I've listed down here. You will need to learn SQL at one point. Some people say it's one of the easiest, but one of the most difficult language because the common SQL statements are not too difficult. Select, delete, and that's all in this phase. And I've listed down Coursera because during phase 1, I heavily relied on Coursera, but I'm making a video about this and I'll release it very soon. This is the phase now that you have learned Python from phase 1. Now you need to learn Python for machine learning. So here you learn heavily on a scikit-learn, train your first model, understand why they fail, and get some math intuition while you practice this code. The tools, the Python libraries that you need to focus on is a scikit-learn, XGBoost, LightGBM. There are a lot more like CatBoost, but these are the main things you should be focusing on. Weight and biases is more of training evaluation platform that you can visually see and organize your training track records. But it's nice to have a habit of machine learning model train tracking because later in the future, if you run over 400 experiments, for example, you'll forget which model worked well, which model didn't perform well. So weight and bias is one of the examples that you can look into in terms of model management. In this phase 2, there are a few to keep in mind. The first thing is you can explain bias and variance trade-off for a non-technical friend. Honestly, this bias and variance trade-off is one of the examples. Try to explain any of the ML basic concept to the non-technical friend. I find this is very important because while I'm working in a AI startup or like in a data science team,
you'll have many chances to interact with non-technical audience. You need to explain why my model works, why my model seems to make sense. You need to explain it to non-technical audience, how to explain the complicated terminologies in an easy way that any audience can understand. Second is you need to know when to use the precision, recall, F1 score. This also means you need to know when to use the common evaluation metrics. There are, depending on what kind of machine learning you are developing, there are certain fixed evaluation metrics. Every evaluation metrics has its pros and cons. So you need to have enough knowledge to explain how the evaluation metrics ABC is different. Third, you can build scikit-learn pipeline with pre-processing and model from scratch. The other thing is you can understand why we split the data, train, validation, and test data. This might sound very basic, but it's very important to visualize all this training validation inside your mind. Because if you get confused or the way that you approach is different, it can easily be leaked to data. This is one of the biggest red flags that you should be conscious when you're doing a model development. And if this data leakage happens, your evaluation metrics will be ruined. The whole model will fall down. The other thing is you've trained a model that beats sensible baseline on a real data set. If there is the model that some other people have worked on, and if you've tried to make some improvement compared to the baseline based on the real data set, it means you know how to make a real change by making your own tweak to improve the model. So the milestone for phase 2 is you need to have at least 3 machine learning projects in GitHub or the Kaggle public notebook with the end-to-end process about how you approach what you did on data, how you splitted the train set, and what kind of model you have built, how you fine-tuned, how you evaluated, and how the results shows. And the end-to-end process covers from the data, reading the data, pre-processing, building model, and evaluating and explaining it to people in the public notebook. Here, the common mistake: don't try to jump to deep learning before you can write the proper scikit-learn pipeline. I think this is the thing I struggled because when I was studying, I was like, deep learning looks way cooler than machine learning. I want to stop learning machine learning, the boring part, and then move on to deep learning. But it doesn't work like that. And in reality, most of the company, if they don't have much big data set, they are still using traditional machine learning models. So you shouldn't be skipping this part or overlook this part because it doesn't look cool. Don't skip the code block part on the machine learning basics books. So if you look at any machine learning, for example, like hands-on machine learning books, which is one of the most popular book out there, they always have this code block about they explain the concepts and then there are code blocks they recommend you to type in and read it. At first, I felt a bit lazy, so I underlined those codes and I didn't write down with my hands. But I really regret that because if I wrote down the code following the instruction, I think I would have learned faster. So for you, try not to skip the code blocks and write down the codes that's written down on the book. It exists there because of the reason. And the other thing is, every book, they mostly have these exercises in the end of chapter. This is also the thing I used to skip it all the time because I felt rushed to move on to the next chapter. But try to pause a little bit and try to think about this. So this is example from Hands-on Machine Learning book. It says, oh, these are the questions that you should be thinking about. How would you define machine learning? What is labeled training data set? These are the questions that you'll face in the interview one day. These are the questions interviewer will ask you. How would you define machine learning? Then you and explain it in your own language. So I've written down here, this is the time you'll get confused. Should I spend more time writing code or should I try to understand more theoretical parts? I recommend spending about ratio between 4 and 6. You should focus a little bit more on a theoretical part because you'll do more coding part on the competition phase. And writing code part is more focused on implementation part. But if you don't have plan, which is based on a theoretical knowledge, you can't move on to writing the code. So the key resources here, of course, my video. I have already taken video about the Python for machine learning. I've listed down the learning strategy that I used. So please take a look and see if it's helpful for you. I've also written down the machine learning resource list. I've listed down all the book courses. I've done some research that people recommended, and some of them are the things that I've also tried. But here I want to tell you, don't spend too much time comparing courses and start and trying to go to like Reddit, like, oh, is this course good or is this book good? Honestly, learning material, the quality of learning material matters, but it's not as important as you learning. You know what I mean? Like, try to choose one book that people generally recommend and try to dive in. Don't spend too much time trying to think about what's the best material, what's the best book.
Sorry guys, video got longer than I expected. I'll see you guys in part 2.